determinants. Okay, so in this video, I'm just going to introduce what a determinant is and how to evaluate the determinants of any square matrix. So let me give you the definition first. So let A be a 2x2 matrix. Okay, so let's say A equals, so let me create a random 2x2 matrix. So A, B, C, D, so very general, the most general 2x2 matrix. The determinant of A is, so the notation for the determinant is we write det of A, or we also write two bars around A, or we rewrite the matrix, but instead of putting brackets, we put two bars. So A, B, C, D. And what all this means the same thing. What is it equal to? It equals to a number, which is A times D minus B times C. A, D minus B, C. Okay, so basically, the determinant of a matrix, of a square matrix, in this case, a 2x2, is just a number associated to that matrix. Okay, what does that number represent? We're going to talk about this in a minute. Okay, for now, let's just do an example on how to evaluate it. Okay, let's go to the technical part first. So for example, evaluate determinant of A, where let's say A is equal to the matrix, I don't know, -1, -5, 2, 3. Okay. So I'm just going to apply this formula. Okay, so solution. So determinant of A is equal to AD, so -1 times 3 minus BC, which is -5 times 2. And so I get -3 plus 10, which is 7. This is the determinant of A, of this matrix. Okay, what does this number represent? And where does this formula come from? Okay, we could ask ourselves the question. Okay, this is not really for this first linear algebra course because we don't do much of transformation, but might as well since we're already here. Okay, so a matrix can be viewed as a what we call linear transformation. Okay, for example, okay, I'm going to see how it works. If I take the matrix, this matrix here, okay, for example, the matrix -1, -5, 2, 3. Okay. If I multiply it by a vector, okay, so the vector, I'm going to put it in column. So let's say you multiply it by the vector, let's say 2, 2, 7. What do I get? Okay, so if I just matrix multiplication, so you know how to multiply, first row times first or only column here, so -2 minus 35 is -37, and 4 plus 21 is 25. Okay, so basically, I took a vector I applied a transformation to it, sort of a function, okay? And it got an image of this vector. So it's like functions that we did before, except that the input and the outputs in this case are vectors. So if I feed to this machine, I feed him the vector 27, he spits out vector negative 37, 25, and so on. I could put in as any vector I want, I will get another vector. Okay, so let's do another example. So -1, -5, 2, 3. If I put in vector, I don't know, 1, 2, what comes out? Well, -1 minus 10 is -11, and 2 plus 6 is 8. That's it. Okay, so any vector has an image when this transformation is applied to it. Okay, so we write basically A times X equals Y. Okay, so just like a function, f of X equals Y. So this f of X is A of X. Okay, okay, I'm gonna go any further than this for now. Okay, no questions on this. Let's move on. And let's check what does this number represent with regard to this transformation. So just as a reminder, A equals to matrix A, B, C, D implies that the determinant of A is AD minus BC. So let's say, okay, let's take, just for you to understand what the determinant means, let me give you an example. So let A equals to the matrix, let's say 2, 0, 0, 3. Okay, let's find, okay, A times the vector 0, 1, and let's find A times the vector 1, 0. Let's see what happens. Okay, so A times 0, 1. So A is 2, 0, 0, 3 times 0, 1. And so I get 0 plus 3, 0 and 3. 0, 3. And if I do A, which is 2, 0, 0, 3 times 1, 0, I will get vector 2, 0. Okay, pretty simple. So what I'm going to do is I'm going to draw the two vectors that I started with, and I'm going to draw the two vectors that I finished with. Okay, so the two vectors that I started with are these ones. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. So we started with vectors 0, 1, which is this one here, and 1, 0, which is this one here. Okay. And I applied the transformation. And what happened? So 0, 1 became 0, 3. Okay. And the 1, 0 became 2, 0. Okay. And what I'm going to do now is I'm going to find the area of this, the area sort of generated by these two vectors, and then the area generated by these two vectors. So this is 1 times 1, the area here is 1. And this is 3 times 2, and the area here is 6. Okay, so the area here is 6 times the area here. What is the determinant of A? Is AD minus BC. 2 times 3 minus 0 times 0 is 6. Okay, so basically AD minus BC is just the factor by which the area between generated by vectors got multiplied. Okay, it could be a negative number. If it's a negative number, it means that it's changed the orientation, the handedness of the space. Okay, but we're not going to go into this for now. Just if you're curious to know what does this number represent, that's what it means. Okay, it's just a factor that gives you an idea of how the space got stretched or contracted or twisted. Okay, that's what it means. We could go into details on finding this formula exactly, but not for now. If you want, ask me in class, I will do it for you. Okay. Now let's say this is for a 2 by 2. Let's say I'm asking you for a any size n by n matrix. Okay, so finding the determinant of an n by n matrix. Okay. Okay, so the best way is just a calculation. So let me show you with an example how it works, and then I'll give you the general process. Okay, so for example, evaluate. So I'm going to write like this: determinant of 2, 1, 3, 1, 0, 2, and 1, 5, 1. So it's a simple question. So we haven't seen up until now in the video how to do a 3 by 3. So we use this is called the cofactor expansion. As follows. Okay, so I'm going to write down 2, 1, 3, 1, 0, 2, 1, 5, 1. So that's what I'm looking for, the determinant equals. And now I'm going to choose any row or any column and expand what we call a cofactor expansions with respect to this row or column. Okay, so for as a first example, okay, I'm going to expand with respect to the first row. So let me just highlight the first row. And I'm going to expand it with respect to this row. So what do? I go 2 times. And I'm going to cross out the row and the column where the 2 is. And I'm going to find the determinant of the remaining matrix, which is in this case 0, 2, 5, 1. So 0, 2, 5, 1, determinant of this, which we know how to do because we know how to find the determinant of a 2 by 2. Then I want to move on to the second term of that row, which is in this case 1 times, and I will do again times the determinant of the matrix that I get by removing row of the row of the 1 and the column of the 1. Okay, so basically I'm left, if I remove this column, I'm left with 1, 2, 1, 1. So 1, 2, 1, 1. And last one is 3 times, so 1, 0, 1, 5, right? If I cross out the row and the column of 3, I get 1, 0, 1, 5. 1, 0, 1, 5. Okay, so 1, 2, 3 terms are pretty easy to calculate, but what do I do with them? Okay, so there's each, you have to know that each position of the matrix has a sign. So we always start with top left as plus, and then we alternate sign like a checkerboard. So minus, plus, minus, plus, minus, plus, minus, plus. And so 2 is in the plus position, so I put a plus. 1 is in the minus position, so I put a minus, and 3 is in the plus position, I put a plus. And this calculation should give me the determinant of this matrix. Okay, I will show you more formally in a few minutes, but just to calculate the determinant, that's how you do. So let's see what we have. 2 times, so 0 minus 10, then minus 1 times 1 minus 2, and then plus 3 times 5 minus 0. Okay. I'm just applying AD minus BC here. AD minus BC, AD minus BC, that's what I get. So I get negative 20 plus 1 is negative 19, and negative 19 plus 15 is minus 4. So this should be the determinant of this matrix, should be negative 4. Let me double check. 2, 0, 2, 5, 1. Yeah, 0 minus 10. Good. Then minus 1 times 1 minus 2 is negative 1. Good. And then 3 times 5 minus 0. Good. So negative 20 plus 1 is minus 19 plus 15 is negative 4. That's it. Okay, so this transformation, if I could see that this matrix transformation, any three-dimensional vector that I multiply hereby, the area generated by 2 vectors will be 4 times bigger and apparently flipped, but let's not focus on this too much. It's not in this course. Just know how to calculate that the determinant of this is negative 4. Okay, let's go in general. Okay, so if I have a matrix, so A11, A12, A1J, A1N, then A21, A22, A2J, A2N, dot, 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 AI1, AI2, AIJ, AIN, all the way until AN1, AN2, ANJ, ANN. So this is an n by n matrix. Okay, so dot, 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 dot. So the determinant of A, okay, calculated along row I. Okay, so I'm going to expand along row I. Will be what? So it will be AI1 times. So I'm going to write something weird here, -1 to the power of I plus 1 times the determinant of big AI1 plus AI2 negative 1 power I plus 2 times AI2 plus dot 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 Aij negative 1 power I plus j determinant of big Aij plus dot 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 in negative 1 power I plus n determinant of ain. There you can see now. Okay. Looks pretty complicated. Okay. But it's really not. Basically, it's just like what we did here. So the AI1 is just like the 2. The negative 1 power I plus 1 is the sign here. Okay, so basically if I plus j, right, if the coordinates, the position is in an even position, when you add the row and column position, if you add them and you get even, it'll be plus, right? If you add the position, you get even, you get it's plus. And if it's odd, if when you add it, it's odd, you will get a minus. Okay, so this is position 1, 2. 1 plus 2 is 3. Negative 1 power 3 is negative 1. It's negative. Okay, so these negative 1 power I plus j's here, they're only the sign of the term. And determinant of aij, these ones, are actually the determinant of the remaining matrix when you eliminate row I, column j. Okay, these are called the cofactors. So this is called Cij, which is actually called the ij cofactor. Okay, of course, this is the in cofactor. This is the I2 cofactor, and so on. Okay, and this, without the negative, this here, this has a name as well. This is called the ij, it's called the minor. Okay, without the sign, it's called the minor. Okay, and that's why it's called the cofactor expansion, because we're expanding along a row or a column. I could have done it, and it's just the number in the term in this position times the corresponding cofactor. Okay, so every position has a corresponding cofactor. Okay, let me just rewrite it in sigma notation. So this will be the sum j goes from 1 until n of aij negative 1 power I plus j times the determinant of aij. Okay, so this is a bit more, looks scary, okay, but what you'll end up doing is not this. This is what you'll end up doing, which is right here. But I just need to show you the more general mathematics behind. Okay, I can't just teach you recipes. I have to teach you what it really, what the names are. Okay, so this is a cofactor, this is a minor. The cofactors are important because we're going to need these when we're going to do the adjoint of a matrix soon. Let's do one last example for this video. Okay, just applying the cofactor expansion to make sure that you don't forget it. So here's the example. Evaluate determinant of A, where, so let me give you a nice matrix. 1, 2, 0, 1, negative 1, 1, 3, 0, 0, 2, 1, 1, and 1, 0, 0, 3. Okay, so this is the 4 by 4 matrix now. So this is much longer, as you will see. Okay. So how do I find the determinant of this matrix? I need to expand with respect to a row, any row or any column. So I'm gonna be smart here. I'm gonna take a row that has a lot of zeros or a column that has a lot of zeros. That way I don't need to find too many cofactors. Okay, so I have two choices here. I could take the last row because there's 2 zeros. That's practical. Or I could take column 3 also because it also has 2 zeros. So let's take column 3, okay? Because we haven't done an example with choosing a column. So let's try. So the determinant of A is equal to, so the determinant of, where we write it, 1, 2, 0, 1, negative 1, 1, 3, 0, 0, 2, 1, 1, and 1, 0, 0, 3 equals, let's expand with respect to column 3. So let's go. So I have 0 times the determinant of what's left. If I cross out the 0 row and 0 column, I have negative 1, 1, 0, 0, 2, 1. Of course, I don't need to write this because it's multiplied by 0, but just for the exercise, 1, 0, 3. Then second one, 3 times the determinant of, so I'm crossing the row of the 3, so 1, 2, 1. Not this one here, 0, 2, 1, 1, 0, 3. Then 1 here, so I cross out the row of the 1, I get 1, 2, 1. So it's 1 times 1, 2, 1, negative 1, 1, 0, and 1, 0, 3. And the last one is 0 times determinant of 1, 2, 1, negative 1, 1, 0, and 0, 2, 1. Okay, and now I need to put in the signs. So let me see, plus, minus, plus, minus, plus, minus. Okay, so plus, minus, plus, minus. Okay, so I have 1, 2, 3, 4 determinants to evaluate. Each one is 3 by 3. Each one I need to do a cofactor expansion again. Okay, so it's pretty long. But of course, this is 0, so I don't need to calculate this one. I'm not going to waste time with this one because anyway, it's going to be 0. So I just need to calculate these 2 determinants now. Let's go. Equals, so negative 3 times. And now I want to do the determinant of this. So again, I'm going to expand with respect to any row or any column. I will take column 1 because there's a 0 here. Okay. So 1 times determinant of 2, 1, 0, 3. 0 times, I'm not going to, okay, I'm going to write it. 0 times 2, 1, 0, 3. And then 1 times determinant of 2, 1, 2, 1. And then for this one here, so plus 1 times, and I will decide which row or column I will take. I will take the third row for this one. Okay, so here I took column 1. Here I will take row 3. Okay, it doesn't matter, any row, any column, you're always going to get the same answer. So let's expand with respect to row 3. So I have 1 times determinant of 2, 1, 1, 0. Then 0 times determinant of 1, 1, minus 1, 0. And then 3 times determinant of 1, 2, minus 1, 1. Okay, the only thing I need now is the signs. So let me see here. Plus, minus, plus, and here plus, minus, plus, minus, plus. Okay, so I always start plus here and then alternate minus, plus. And here I start plus, minus, plus, minus, plus. So plus, minus, plus, and here again, plus, minus, plus. That's out, that's out. Okay, because I'm multiplying by 0. And what do we have? Negative 3 times, so this is 1 times 6. This is finished. 1 times this is 2 minus 2 is 0. And then plus 1 times 0 minus 1, so that's negative 1. Plus 3 times 1 plus 2 is 3. And this is my determinant. What do I get? 6, negative 18, that's 0. And what do I have? 9 minus 1 is 8, and 8 minus 18 is negative 10. And this is the determinant of this 4 by 4 matrix, negative 10. Okay, so basically, at this point, you should be able to evaluate the determinant of any n by n matrix, any square matrix. Of course, if it's a 5 by 5, it's going to be huge, okay? Because you're going to expand, you're going to have 5 of these, and each one will be a 4 by 4, and each one you have to do all this again, okay? So there's definitely an easier way to evaluate the determinants of a matrix, and I'm going to show you this in the next video.